Kia ora koutou. This is question 1D from this year's algebra paper, and the paper only came out today, so I'm just doing this question quickly for people who kind of want to know how to do it, especially if you got stuck on it in the exam. So this question, I think, is quite challenging if you don't start off with just trying to draw a graph of what's going on, and you have to sort of read it pretty carefully. We're told that 2y is equal to 2x plus 29 is a tangent to this quadratic. Now, this quadratic is x squared minus 2ky plus 32k. And the first thing that should hit you over the head as being weird is that it doesn't have an x here, it's got a y here. Usually, our quadratics are written like this. If we're doing a graph, we might have x squared plus 5x plus, I don't know, maybe plus 8. Right? And then to draw that graph, we have got three ways to write that quadratic. We can write it in expanded form, like it is here, where we can read off the intercept, the y-intercept as being 8. Or we could write it in vertex form, where we've got this, or we could write it in roots form. Now, this one here that I've done doesn't have nice integer valued roots, right? But we could work those out. And at level 2, we learn how to do that with the quadratic formula, blah, blah, blah. But this quadratic is different because it doesn't have y equals to anything. It has y buried in here. This is pretty straightforward. This is the equation of a straight line, of course, because it's a tangent line. So we're going to do a little bit of work before we really get into the question with what this tangent line is. So we've got 2y is equal to 2x plus 29. Now our brains are used to seeing equations written in the form y equals mx plus c, so let's do that now. This straight line is equal to y equals x plus 29 divided by 2, which gives us 14.5. And if we look at the graph of that, you can see that we've got just an ordinary straight line, right? It's going through here. What are we told about that tangent line? Well, we're told that it's tangent to this quadratic. But this quadratic has not got y equals anything. It's got a buried y in here. So we're going to start off by rearranging this to make y the subject, and then see if that helps us understand what's going on. We've got x squared minus 2ky plus 32k is equal to 0. And our job is to figure out what k is to make this line a tangent to it. So making y the subject here first, we get x squared plus 32k is equal to 2ky. We know that k is not equal to 0, so that means that we can divide both sides through by 2k. And we'll get 1 over 2k x squared plus, and I'm going really slowly here, 32k divided by 2k is equal to y. That gives me an equation for y that suddenly looks like a much simpler quadratic. Y equals 1 over 2k x squared plus 16. And we should start to feel like we know what that's going to look like, right? We know that that's going to have a y-intercept of 16 up here, and this is my scale factor. So the parabola could look like this, or it could look like this, or the scale factor could be negative and it could look like this. But that's what we're working with. And we want to know what the value of k is that's going to make this straight line a tangent to this one. So this one is set in stone, and this one is going to wiggle around depending on the value of k. So let's go back to that first graph. And now we've got y is equal to 1 over 2k x squared plus 16. So we can put 16 onto this and figure out that what we're looking for, I'm going to try and draw a smooth curve, but it's going to go wrong, is the value of k that's going to mean that the straight line just touches that graph. So my hand's wiggling there. So it's going to be something like that, right? You can see already that this is going to have to be a positive number. And we just want the intersection of those two things. We want it to be a tangent, right? So we want there to be only one solution to this y value being the same as this y value. And that should give you a clue that this is now going to turn into a discriminant problem, right? We're saying we don't want to have it that it cuts through. If it cuts through, we'd have two solutions. And we don't want to have it that we'd have no solutions. We want to have one solution. One solution means the discriminant is 0. And I think once you get that idea, this question is not so bad from this point on. So going back to the question, I'm going to erase some of this. I'm going to keep the rewritten version of the tangent, y equals x plus 14.5. And I'm going to pop back up where we got to down here. So we need this and we need this. And we're going to solve them simultaneously and figure out the conditions for having only one solution to that quadratic. Okay, so off we go. We want to know when is 1 over 2k x squared plus 16 equal to x plus 14.5. I'm going to rearrange that and get a quadratic. So we'll start with that. Take away x, take away 14.5 equals 0. So I'm left with this. And I need to explain what I'm doing, right? So a bit of a graph would be a really good thing. If I were marking this and I saw a graph at this point, I'd be so happy. So there's my 14.5, and I'm looking for, I know that it has to go through the 16, and so that's what I'm trying to do, is where is this point? We need b squared minus 4ac equals 0 to have only one solution to this equation here, right? Call that equation star. And now we're going to work out our discriminant. I think it's worth going slowly and writing out a is equal to 1 over 2k, b is equal to -1, and c is equal to positive 1.5, right? Just be really careful that you've got a negative sign there. Sign errors are so easy to make. So b squared minus 4ac is equal to -1 squared minus 4 times 1 over 2k times 1.5, and that has to equal 0. Cleaning that up gives me 1 minus 6 over 2k is equal to 0. That simplifies to 3 over k. So we get 1 is equal to 3 over k, which gives me k is equal to 3. Now let's see what that looks like. When k is equal to 3, we're going to take this back up here. We're going to pop it in here. And we're going to have a look at the graph. So when k is equal to 3, what do we get? Well, then we have y is equal to 1 over 2 3s is 6, 1/6 of x squared plus 16. And the question asked me something that I actually could have answered much earlier. Find the value of k and determine where the quadratic crosses the y-axis. So we actually worked that out really early as soon as we made y the subject of this equation, right? Because we had 32k divided by 2k. So that's the answer to the second part. The quadratic crosses the y-axis at y is equal to 16. But we had to find the value of k. Now don't hang up. I want you to have a look at the graph of this because I think it makes the whole question make sense. This is the finished graph. Now obviously you can't do that in the exam, but you can use your graphics calculator to have a good look at it. So there it is. When k is equal to 3, we get 1 over 2k is equal to 1/6. So we have y is equal to 1/6 of x squared plus 16. And you can see that we've got our point of tangency where x is equal to 3. The question didn't ask you to find that. It asked you to figure out this point here. Thanks very much for watching. I hope there's no mistakes in this. I'm sure someone will let me know if there are. And I think this was a very, very tough excellence question, but I do kind of like it because it tests your abstract thinking skills. So a very challenging problem. If you did get the whole way through this, a big well done. And if you didn't, hopefully you got a good way through it and you understand how to do it now.